Hello everyone. Today I have a very critical topic for our CPU. Have you ever faced the issue when you are working with embedded system and you see your CPU is running near to 100%? This is not good for embedded systems because it degrades the system performance and system life. The main issue might not be your code logic or processor speed, but how you're dealing with internal or external GPIO events, whether you're using polling or interrupts. So polling is when the CPU constantly checks a sensor, like a temperature or distance sensor, at regular intervals. It keeps asking, any change now, even when there's no update. This wastes CPU cycles and power. But interrupts work differently. You configure the sensor to trigger only when a specific condition is met, like crossing a threshold. The CPU stays free until that event happens. Then the interrupt signals the CPU to act, and afterward, the CPU gets back to whatever it was doing, saving time and reducing CPU load. Now let's understand this with a simple project setup. We're using the PSOC 6 Pioneer kit with a TFT display. To demonstrate the difference, we're monitoring a GPIO button using two methods, polling and interrupts. In the polling version, you can see the CPU continuously checking, is the button pressed, over and over. Even if nothing happens, the CPU stays busy, wasting cycles. But in the interrupt version, the CPU remains idle most of the time. Only when the button is actually pressed does it react, immediately and efficiently. So when to use which? Both methods are important in some cases. Interrupts are perfect when events are rare but important, like button press on GPIO, UART receive interrupt, network packet arrival. Where polling is useful in scenarios where precise timing or hardware limitations exist, like ADC sampling at fixed intervals, battery voltage checks every minute, or even radiation monitoring, where you may need consistent scanning. So I hope now you get a clear idea of what polling and interrupts are. See you in the next video. Till then, like, share, and subscribe.